So why do we design? How do we design? How will we describe this? Um, in many cases, the reason why we're designing, or the reason for design, is the need to innovate, change something, if you will. Maybe the introduction of a new product. What we see here in this figure is the three C's um, coming out of a group related to SIR, as previously discussed before. Um, and what these three C's represent are the customer, the capabilities of the company or those parties that are involved, and then finally the competition. And within there exists this nice white space that is ripe for the opportunity to innovate and is worth a good deal of design efforts. And the understanding of what this region is comes from um, the appropriate level of research, investigation, as well as discussion with stakeholders and those involved with the product, whether it be the current state of the art and or your future product that you're looking to work on as you go through with your design sequence. So what I want to begin this discussion with is returning once more to our conversation with the work and example that is mentioned in a lot of the recorded lectures, the autonomous bicycle. So the project management discussion kind of concluded uh, with the mentioning of several scopes, and that they were tied, or scope specifications, in particular performance specifications that were connected to some quantitative um, metric, um, and that's good. But one thing when moving forward with our project, and one thing that I will return to at the conclusion of this discussion, is to have enough foresight and understanding of the entirety of of the project sequence, or the design sequence, if you will. And that's actually the nice thing that comes from the structure that is provided within Capstone, and is that it allows for some of this foresight so that you can plan accordingly and keep those needs in mind as you work your way throughout the entirety of, of the design sequence. So what I'm making mention here is that the project scope should consider the manner in which you'll go about verifying the achievement of the needs that were brought upon from consideration of the baseline requirements. So what we see here is our autonomous bicycle, and we can see the methods are considered now. Granted, these won't be necessarily mentioned within the project scope, but as we'll see and we'll continue to discuss, the manner in which you will go about verifying and then later validating the achievement of your stakeholder requirements should be within your mind throughout the entirety of the project, because you want to make sure that any necessary equipment is available, or technologies required in order to perform the necessary tests are also available. So what we see here, getting back to the very specific example, is that we have our clear metrics here, and they're pretty good as is set. But with that said, they're kind of also putting us in a bit of a box, and I'll get to the reasoning why in a little bit. Um, Not so much the weight constraints, which are kind of associated with more so structural performance or structural characteristics, which should potentially incorporate some factor of safety in order to make sure that these structural characteristics are indeed accounted for. but more so the aspect of the autonomy as well as the speed are aspects of the original proposed scope that I'd like to touch upon a bit further. So when creating your scope and within your conversations with the stakeholders, it might be useful to consider the inclusion of target goal metrics as well as acceptable limits. In this particular example here, what we see is the goal for this particular project is associated with a printer in which we have our target specs or metrics, but then also acceptable limits, in which based upon interaction with stakeholders, trade studies, and other such things, we have determined that the uh, the goal for associated with the baseline user need or requirement can still be achieved if we hit these limits or within this range. Um, some of you may have heard before the terms needs, goals, or objectives, and GOs. It's within the framework set out by NASA and so forth. But really, what apologies. Anyway, so really, what you look to do is look to make sure that the needs of the project are clear and translated from the baseline stakeholder requirements that are provided, and then the goals that will be associated with those needs, and then the objectives where the quantification of those objectives is mentioned. And here we have an example of of the translation of one of the performance specifications from our prior example into this form. So the bicycle shall travel at speeds expected for recreational to experienced riders. And that performance characteristics I have just simplified to a straight line velocity. For a table, perhaps in some of your documentation, you would have the actual um, need statement translated from the stakeholder or customer requirements. I have the target speed being about 20 miles per hour, but acceptable limits 12 to 25 miles per hour. Because when it comes down to the actual testing, there are definitely some parameters that are associated with the testing that could be out of your control. And then also based upon conversation with stakeholders as well as review of what is the common speed for different bike riders, we can determine that this is an acceptable limit for our autonomous bicycle. Now, on the other aspect of the bicycle being autonomous, and I don't necessarily know why you would want an autonomous bicycle in which you yourself are a passenger on, um, but I believe also that performance characteristic could also be defined in a better manner, um, considering the fact that the vehicle must be capable of navigating and operating without human input. Further consideration and definition of this statement, I think, would be useful. Um, so take that into consideration as you look to define the different performance characteristics and constraints of your project. So in doing so, and I believe some of this material may have been covered in some of your prior classes, but in the expression of the need statements, try to avoid the terms must and should, as these evoke not necessarily the most positive of emotions, and implicate like a degree of obligation and or judgment. So the terminology is always very, very important, and a discussion with the stakeholders should be had as well as with your project advisor. Look to use positive phrasing, express the need as an attribute of the project, and express the need in terms of what the project has to do and not what the project might do. Um, so we can discuss that in further detail if if you need. Um, In many cases, what you may see is these statements are expressed as shall statements. Um, so that's kind of the example in this case. So there are a lot of different subcategories of project requirements, and there exists a strong need for stakeholder interaction in a very iterative fashion. Functional needs are very important. Performance interface characteristics. Remember that every project or product that we look to design sits within and interacts with a variety of systems, and that holds a degree of implications. Um, Among some stakeholders that might potentially be forgotten could be the interaction with potential fabricators, if you will, or manufacturers, and in which case there exists a need for clear communication throughout. We have our capstone filter in which we talk to both the stakeholders as well as our internal and potential external fabricators, but there exists different needs in communication to these fabricators. And then also at the same time, this is a good opportunity to potentially discuss like the design for X, which are guidelines that one could use to optimize your product for certain parts of the life cycle. If those parts of the life cycle have been found in your research or in your discussion with the stakeholders or customers to be um, kind of pain points within their interaction with the product that you're looking to design. So in this particular case, the most clear one that would come to mind would be design for manufacturing or manufacturability, if you will, in which that could be potential important consideration uh, for the uh, for the stakeholder. Um, Throughout the entirety of your project, the need to break down the project into its different components uh, is important. And here we have some potential functional statements if we're going to decompose our project around something which seems fairly obvious, which is the function of the object. What we could look at potentially is the different functional requirements as set out from our conversations with the stakeholders and our need statements. We could look at what is currently out there in terms of the baseline and break down those functional components in order to determine where we might want to potentially intervene with regards to the system that is the product. At the same time, also when we're breaking down these different functions, different team members could take responsibility for each of these sub-functions or subcategories of the project and find ownership in that manner. So um, project decomposition is very important, and you'll find it in a variety of components in the design sequence, from the project definition to the conceptual design phase to the potential cost estimation and other such components of our and many design sequences that you find yourself in. So then, as you break down the function, you could potentially map the function. In this case, we have a power screwdriver map broken down here, in which you can see some of the different functions, and all the while, what you might also make note of, especially for existing projects or products, are pain points or risk uh, components associated with these different projects, if you will. Um, um, and I kind of bring up the concept and the idea of risk as the manner in which we manage risk should be considered throughout and from the very beginning of the project. So there should be a log, if you will, of potential of failure mechanisms as well as an understanding of the severity of those failure mechanisms as you progress throughout the project. And now this will be easier to do uh, when the design moves into the detailed design phase. Um, but at the same time, it should kind of be a run and work or a live document of some sort in which you consider some of these potential modes for failure. And it really starts from the onset as some of these modes of failure should be mentioned and um, weighted based upon the input from the stakeholder and customers. Similar, the different project requirements and specifications will also be weighted based upon the needs of the stakeholders and customers for those are whom we're looking to design and innovate for. A greater degree of understanding and also evaluation of the problem can occur by connecting the function to the structures that perform that function. In this case, we look at the hair dryer example, in which case we can potentially ideate around those different structures, and we have two different categories on which we can design around, both function as well as ideation. Um, and ideation and the creative aspect of that within the design is a very interesting topic that hopefully you guys will discuss a little bit within your group with your stakeholder as well as a class. So um, kind of returning to one of the chief points that I tried to make at the onset of this video is that there exists a need for foresight throughout the entirety of the project. And the design sequence I've set forth for you uh, and the fact that you know the upcoming steps allows for you to incorporate some of this planning and potential documentation as you work your way through your design or through your project. Such aspects to consider are and keep track of throughout are stakeholder expectations, the relation of the design solution uh, within those aspects of the system. Um, how are you going to realize your product? What will testing encompass? What do we anticipate the results of those tests to be? Um, and then technical management. How are we making decisions using the input we receive from the users early on in terms of weighting? As we can see here, uh, there there are a variety of inputs within this particular table in which we have a certain weight associated with design maintenance in this particular case. Um, and this is associated with a more so like risk analysis, as we can see in this wishbone diagram here. But where those inputs or those weights come from, they come from the customers and the stakeholders. They shouldn't necessarily they shouldn't come from the design team. So those are inputs that we gather very early on and continue to discuss with our stakeholders throughout the entirety of the design process. So a lot of these aspects should be incorporated as you work your way through. Um, Hopefully, this has been clear and adds some intriguement into different tools that you can make use of in order to ground your decision making and your analysis in some tried and true methods.